So we saw earlier that the depth of topology that get impacted whenever there is a change needs to be avoided. And also we saw when primary path goes down, when a path goes down for a destination, and when there is no backup path, but you got a lot of neighbors, where one neighbor you were reaching the destination, but that one neighbor said the destination is no more available. You got other neighbors like hub and top design, hub and topology, hub and spoke design. You see this B. B lost the connection to reach this particular network via this regional office router. There is some router here. That router came and said, an update came and said to B, hey, this network is no more via with me. It's no more with me. It's gone. So B has got other neighbors, which means there are chances for an alternate path. Maybe this D router may be connected through some other slow link. D may be connected to some slow link to the same network to which the network path is lost. So because that feasibility condition is not met, that path via D might have not been considered. So when the primary path goes down, the EIGRP protocol need to discover by querying. But the problem is, we saw here, the queries are sent to every neighbor, not only to D. So not only to D it is sent, because B really don't have any idea whether D has got it or C or E or A. No idea. So the queries are sent to all EIGRP neighbor routers on all interface except the interface of the successor, meaning the route which has gone just now. This is successor route. Except this direction. Via all other direction, the query is going to be flooded. If the neighbor do not have the lost route information, the queries are sent to their neighbor. This is where the problem is. This is where the depth of the topology, the number of the routers that are involved in the topology chain, all this comes into picture. These are the things that influence the scalability of this protocol. So we need to somehow stop this query sending to all neighbors in all direction. Why? Even if there is an alternate route, for example, in our case, D has got an alternate route. D comes and says, I got a route. But B cannot take it. Sorry, B will take it, but B cannot use it immediately because B also have got other neighbors. B want to confirm that the other neighbors don't have root, or B want to confirm that there is no other route best than via D. For that, B will wait for the responses from C, E, and A. See, D, according to our assumption, D has already given. According to our assumption, D has already given the route, saying I got a route. And B, you don't put that route in the routing table. B needs to finalize it. B needs to compare the C's response, C, E, and A's response. But C and E and A, they are not going to respond at all because they are nowhere connected, no way connected. There is no path to reach that network. Our assumption is this is somehow connected to this network. No one else. But they all got some routers. They all got some routers running EIGRP. So if E don't have the response to give, it's going to send the query to their followers. Query, query, query. The query goes on. Oh, now everyone is going to wait for a response. Not only B is waiting, E is waiting for the response. And E's followers are waiting for response from the downstream. Like C is waiting, A is waiting, every router is waiting. And then what? And then they wait for 3 minutes like this. See, in these 3 minutes, they are all sending hellos. No problem in the hellos. They're all sending the hellos. But they got a problem here. Even though they're all sending hello, the response given by D, if B need to use it, two things should happen. Any one of these two things should happen. Either C, E, and A should give a response, or they should come with some reply. C, E, and A should say, "We don't know." That is also a response. We don't know the path. C, E, and A should come and say to B that you sent me a query for this network. My response is, I don't know. I don't have the root. Or, in order to choose what is given by D as a route, in order to use the route given by D, in order to consider the route given by D, B should remove C, E, and A from its neighbor relationship. Only then that query that was sent for which the response doesn't come back will be cancelled. B has sent a query to C, E, and A. Either you should receive response or it needs to be cancelled. Means the neighborship itself needs to be cancelled. That query should get nullified. The query should get nullified. For that, C, E, and A should be removed from the neighbor. Only then there is no other neighbor to wait. Whatever D has given can be used by B. So this is going to be a very bad disruptive one. Why? When B removes C from the neighborship, there may be many networks learned via C. These routers might have learned many networks from C. and that those roots came from B. Those roots don't have any problem. But because B is saying C is no more my neighbor, all those roots that was via B will be considered as no more available. See, it's one network creating how many problems. And when this decides that those networks via B is no more, that information will be sent triggered immediately, and they all remove the roots which was via B. Actually, those roots are still available, but because B has removed C from the neighbor list, just to consider the root given by D, just to consider those roots given by D, it has to remove the neighbors. When the neighborship is removed, the downstream router's neighborship will also be questionable. They will also get a trigger update saying all these networks which was going via B is no more available. In short, if I need to say, the entire network will go down. Not only just connection between B and C goes down, and B and E goes down. Not only for between B and A goes down, the entire autonomous system will go down because everyone is waiting for 3 minutes. They will all remove their neighbors. The entire EIGRP running autonomous system will go down. See, this is how EIGRP is designed. It may sound like why they have designed this bad. Why can't they correct it? See, there is no other option according to the EIGRP designers to pick the route given by D, to use the route given by D. In order to use the route given by D, two options only. C, E, and A should give a response, at least by saying, I don't know. They should say at least that thing, but C, E, and A is not saying that. Instead, it is querying very sincerely to their downstream, and they are also waiting. Everyone is waiting. Only when they get the route, they will respond. If there is no route, they will be simply forwarding it to the other downstream. At last, the route given by D is used by B after a big chaos, and then everyone starts re-establishing the neighbor by sending hello, as if the network is coming for the first time. This is a very, very disruptive behavior of EIGRP in hub and spoke design. This hub and spoke design. So the solution is stub. So what is the stub provides as a solution? What sort of solution? How this can be solved? Very simple. All these routers they need to tell to B router and A router. A and B happens to be a hub. Likewise, A and B looks like a hub for C, D, and E. And if you see from other direction, for B and A, C is a hub. For B and A, D is another hub. For B and A, E is another hub. Isn't it? For E, A and B looks like on spokes. So what I'm trying to say is, in all spokes, if you see from left to right, C, D, and E looks like a spokes. If you see from right to left, B and A looks like a spokes. In all the spokes, so let us not focus on B and A now. Let us take only one. A and B are hub. Let's leave it there. A and B are hub. C, D, and E is spokes. Now you need to go to all the spokes and configure stub so that these three routers will go beforehand, before the problem starts, before you lose that network to regional office from B, before you lose that network going to regional office from B, before that, beforehand, the C, D, and E will go and report to B, saying, I am only capable of doing these things. So that anything within that limit, B will query. B will query only those things that are within that limit. Okay, so unnecessary query which is not possible will not be done. See, for C, providing a route to reach that regional office is not possible, but B is querying, that is where the problem started. Another place where the problem started is C is not responding to B, instead it is forwarding it to downstream. It's forwarding the queries to downstream. So the third paragraph says, the third point says, the stub router sends a special peer information packet to all neighbor routers to report it's a stub router. Meaning, it's a special packet which is going and telling the hub router that I'm responsible only for these many networks. If you need anything related to this, I'm okay to respond to you. Otherwise, don't come to me. See, the fourth point says, the neighbor that receives the packet informing it is a stub does not query the stub router for any routes. These are the 5 different types of stubs. If you simply configure stub without saying what type, if you simply put this command EIGRP stub under router EIGRP, when you simply put stub, you don't mention any of this. What does that mean? It means that you are enabling connected stub and summary stub. See, that's type 2 and type 4. When you simply configure EIGRP stub, the default will be these 2 types. These 2 will be enabled by default. Connected and summary. Now, what is connected? So the one is already over, okay, out of 5. But we have not gone into deep what these things will do. I'm going now. So the first one is simply stub, which is going to enable stub connected and stub summary. Now what is connected means? Type 2. Let's see. What is the second type stub? When you say EIGRP stub connected, what it is going to do? That router will inform the neighbor router, in our case, C, if it is configured as a stub, it will inform to B and A that these connected 3 networks, only I know. I'll not respond. First of all, I won't know. I do not know anything about any other network except the connected networks. Let's say here 10.16.0.0/16. Here 10.24.0.0/16. Here 10.96.0.0/16. So C will tell to B, hey, these three subnets, I guarantee. So not only it is advertising those networks, it is also putting one small note saying only these three things I know. Only these three things I know. These three connected networks that are configured on my interface, I know. It indirectly tells B that don't ask me other than this. Problem solved, you see. B is not going to query and B will not get stuck in active. Which is 3 minutes. What is stuck in active? See, when the primary goes down, when the primary path goes down for a destination, when the primary path goes down, B send queries during that time, till it gets response. It will be the searching will be in active state, searching of path, sending queries, waiting for response. And during this time, if you go to topology table, during this time when you go to topology table, for that destination you will see A. A means active. Yeah. So we call it a struck inactive because for 3 minutes it is stuck. It is not deciding anything. Even though D is providing a route, even though D provides route to B, B is not taking any decision. We call this struck inactive. Active state, it got struck. Meaning B says, I still don't have a route. What? D has already given you. But B says, no, I need to wait for other three members to respond. So B couldn't decide. We call this struck inactive. SIA. SIA. If you type this command, show IP EIGRP packets, and also in summary, you will see struck inactive, SIA mentioned there. I'll show you when I do the lab. So connected, if you say permit stub to send connected routes only. That's another thing. Not only it sends a special note saying only these three you should ask me, only related to these three you should ask me. It also advertises only the connected route from the routing table. Two things here we are learning. When you don't say EIGRP Stub connected, it used to advertise a lot of network that it learned from downstream. But after you say EIGRP Stub connected, it stops advertising those routes learned from downstream. It advertises only the connected routes. Please understand, I repeat again. If I configure this router as EIGRP Stub connected, see, this C might have learned a lot of network, let's say network A, BBB, C. Now C has got routes to reach AAA, BBB, CCC. But as soon as you configure EIGRP Stub connected, C will stop advertising about BBB, CCC, AA. Because you said what? Stub connected. So C will say, I got only this network these three networks on this interface. Only for these three networks I am responsible. For the rest, do not come to me. So even though C can reach A, B, and C, even though the routes are available in C's routing table, router C routing table, C will not advertise it to B. Right. So this is EIGRP stub connected means. If you will configure stub summary, which is also the third type, it not only advertises, it will not advertise B, C, A, not only these three it will stop advertising, it will even stop advertising its own connected network. It won't advertise even the connected network. If there will be any summarization done by us, only that summary route it will advertise. See what a nice feature it is. In real world, we do summarization and we want to advertise only the summary route. This is a very good option. Do summarization and then tell router that advertise only summary. Don't advertise any detailed route. By giving this command, router EIGRP 1 EIGRP stub summary. EIGRP stub summary. So only the summary routes are going to be seen on the hub router because these folks don't advertise any detailed routes. And any other network, if hub wants to know, it won't query. Anything related to the summary of the route given, then it will query. See, you need to imagine a few things so that you will understand why this is so nice, good. You see, in the real world, the networks that are found in here, all this will be same class, but subnetted. So if you do summarization for these networks here, and when I advertise only the summary route, anything goes, any network, like if it wants to go to, if it wants to reach the network here, let's say 10.128.1.0 128/16, you might have already advertised saying anything that is 10.0.0.0, you come to me. That's a summary. So if B wants to know about this network, definitely query will go here. Because C has told that this network, I'm responsible. It won't go to any other router because they have not taken the ownership. So stub connected we know, stub summary we know. I repeat, stub connected will advertise only the directly connected network. If there will be any summary route, it will not advertise. If there is any other network learned from the downstream, it will not advertise. When I configure EIGRP stub summary, it won't advertise connected. It advertises only the summary route, if any, on the router. Now you see, when you simply configure stub, you get the advantage of both. Actually, if you have these two, for properly designed the EIGRP autonomous system, this two is what needed. These two together is what needed. Because we want to advertise our own connected network, and also we want to take ownership for those downstream networks, but in a summarized way. So usually we do summarization. If you have many subnets. So when I advertise summary route and the connected route, which means I'm taking ownership of all the available routes, all the available networks. That's why they have come up with this idea. Default, mostly everyone will like this. So they have put these two together and they've given us in one. Sometimes people may not like to advertise the connected, so they may go with this. Okay, well, we have seen three types of stub. Now the fourth type is, let us say you have in this router, you also have some static route. To reach some destinations, we also have static routes because in that direction, the neighbors are not running EIGRP, assume. In this direction, we don't run EIGRP, no EIGRP. But we do have EIGRP here. But in this direction, no EIGRP neighbor. So what we have written is we have written some static routes for the destinations here. Static routes. We have written some static routes. Now that static route we have also redistributed into EIGRP so that B can reach those destinations. We have redistributed. We'll have a separate chapter on redistribution later. Now in a simple way, if I need to explain redistribution, as the word says, redistribute. Again, you distribute it. What you can redistribute from static again into what? EIGRP. That is a redistribution. I can redistribute from OSPF into EIGRP or BGP into EIGRP. This is not called as redistribution. Taking routes from some other source, giving to EIGRP is a redistribution inside EIGRP. Originally, the network, to reach the network, originally we have a static route. But I'm redistributing into EIGRP so that EIGRP routers will also know about those destinations to which I have written static route. Now I'm going to say EIGRP stub static. When we say EIGRP stub static, that router will advertise only the redistributed network, only the static route which is redistributed. It will not advertise connected, it will not advertise summary. It advertises only the redistributed route, the only static route, the redistributed route. Other than that, all other thing will be filtered. And there is a special note again saying only for these networks I am responsible. Right. Next is receive only. Receive only, as the word says, it is not going to advertise anything. Yes, EIGRP, they form neighbor, but they don't advertise anything, neither connected, nor summary, nor static redistributed routes, nothing it will advertise. It will not advertise any network information, but still it will have neighborship. On the other hand, it learns everything. Listen, C will not advertise anything. It will say, see, I don't have anything. Simple. That one small note will go. C will send a note to B, I don't have anything. Means I do not want to give you anything. So don't come to me for anything. It will send that note. But whatever B gives, it will be learning. And it will be advertising to the downstream. If there is a downstream router, EIGRP enabled, it will be advertising. Whatever B gives, C will happily take it and forward it. But what it won't do is, whatever it learns from here, it will not give. Even the directly connected, it will not give. Hmm. So this is how the 5 types of stub goes. We'll do this lab. Here we got hub router and 2 spokes router. And you see router 2 also has got some downstream, just one downstream. For example, I have taken, this is more than enough number of routers in order to understand 5 type of stub. Right, we are going to see one by one. Before that, let me start this. As I said, this is the used one. In previous batch, I'm going to remove EIGRP. Other than IP address, I'm going to remove all the other configurations. EIGRP we configure under router mode. So if I remove that routing protocol, everything gets removed. If I remove the routing protocol, everything gets removed. You remember I told you the other day, the easy command to remove all the routing protocol in one go is, do you remember? The command that will remove all routing protocol.
No, sir.
No IP routing. This command removes all routing protocol that you have. You don't need to go and say no router EIGRP. See, if I don't know this command, what I would have done, I should know first what EIGRP running. I'm running EIGRP 10. First, I should know that. For that, I would have typed show IP protocol. And then I would have said no IP router EIGRP 10. This is what I would have done if I don't know this command. Not only on this not only on one protocol I put no, I said I want to remove all protocol. Assume I have 3 routing protocols running. BGP I'm running, EIGRP I'm running, I'm also running some maybe let's say OSPF. I should have said no, no, no for all these three. But I tell you, just one command, no IP routing, can remove any routing protocol that runs on the router. But don't forget to put this back, otherwise the routing will not be supported. This is very important command. This command makes the router to work as a router. Okay, now I want to show you after removing EIGRP how the router looks like. Show IP protocol. It says there is no routing protocol. Nothing. Empty. IP routing, NSF aware, nothing. It's not aware of anything. This simply means router. So we don't have any protocol. I want to show you on the other router. Before I remove, I want to show you the same command. Show IP protocol. You see, it shows that you got EIGRP 10 running. And if you will have other routing protocols, all will be listed here one after the other. And just by putting no IP routing, I am gone. Router 1 and router 2 is over. Router 3. No IP routing. And then put back. Okay, one more router. No IP routing. Put back. Routing. Right, done. So we got routers which has got no routing protocol, but IP addresses are still there. I want to show you that. Show IP route. You see, if you don't have IP address, you will not have all these connected networks. This is the IP address over the link. So IP addresses are there on the links. Show IP interface brief. You can see here. G3/0, which is this one, has got 24004 and it is up. I no need even type no shutdown. So other than routing protocol, all the rest will be there. All the other things are there. Next, yeah. Show run interface G3/0. I'm just checking this interface status. Looks good. Don't worry about negotiation auto. This is not configured by me. It is there by default on the router. This is talking about the duplex negotiations. If one side is half duplex, if the other side is full duplex, and then the problem is the one side which is half duplex cannot cope up with the full duplex. So there will be some issues in communication. To avoid that, before communication starts, they negotiate and they come to a conclusion whether need to be there in the full duplex or they need to drop down to half duplex. So if one side is half duplex, other side is full duplex, the full duplex will come down to half duplex so that both sides they will have match. So likewise, speed will be negotiated. So they negotiate this. This is not. This can be configured manually, but not necessary. These are all automatic, and that's why they have put this command by default. I did not configure this command actually. All right, now let us go to router 2 and see if any configuration on the interface. Show run interface G3/0. Even here we don't have any extra other than IP address and the default no negotiation auto. What is next? I would like to check even on R3 because these are the two routers where I'm going to configure. Router 2 and 3 are the two routers where I'm going to configure stub. Right. Let us now go and enable EIGRP with no stub initially. Later we'll introduce stub. Okay, so this is where we go. Router EIGRP 10. Let's make it 100 this time. Networks are 13. Network 3. See, when you are advertising some network, if you wish to match 24-bit, you can use wildcard mask. If you wish to match 32-bit, you can use wildcard mask. Otherwise, if you simply hit enter without saying wildcard mask, even if you would have typed this, it looks like 24-bit. We have mentioned no. Actually, when you don't mention the subnet mask, when you don't mention the wildcard mask, it will take classful. I want to show you that. You see, I have typed 33333, but it would have taken 3.0.0.0. Do show IP protocol. When do I type do command? Whenever I do not want to go to the privilege mode. See, all the show commands works in the privilege mode. If I don't want to go there and type, because I need to type exit, I can simply put do. Okay, but the tab will not work. The autofilling will not work here. We have to type everything manually. Show IP protocol, you see, even though I said 3.3.3.3, it says the network that it is running is only for 3000. Now I remove this. I'll also remove this, which one, 13. And if I want to match exactly the prefix length that is mentioned on the interface, over the interface, the mask that is mentioned is 24 and 32. Then what I should do is I need to say network 13.0.0.3, or if you want to match 24-bit, then you need to say 0.0.0.255. This is how the wildcard mask. You see here, there is no mention of /24 or 16 or anything, which means it's default class. 13 default classes class A. 3 default classes class A. Network 3.3.3.3 wildcard mask. All 4 octets should match. Only then that interface can run EIGRP. So 3.3.3.3 is matched on loopback. Let's verify that. Show IP in EIGRP interfaces. You can see it runs on loopback because this is what the 4 octet in that loopback. And here it runs because this 3 octet is what on G3/0. Even here in the picture you can see at the background. So wildcard mask you should use to match the maximum prefix length. Now show IP protocol, you will see there the masks mentioned very clearly. Earlier we were not seeing this because we use the wildcard mask and say match exactly this one, and which is classless. For classless only it will show like this. For classful it won't.
Sir, I've got a question.
Yes, please.
By doing this, would the router gonna show the prefix length network, or would it show the summarized network?
Okay. See, In the earlier version of EIGRP, the summarization was on, so it will even though you advertise like this, it will show only the summary of it. But the newer version, the summarization is disabled, so it is going to show the actual length. Listen, one thing I want to nail it very deep, whether you use wildcard mask or not. Whether you use wildcard mask or not, this is a classless routing protocol. If the summarization is disabled, even if you don't use the wildcard mask, even if you don't clearly say 24, 32, even though you don't say this, while advertising it will advertise 24 and 32. Now what is then what is the use of wildcard mask? Why do we need wildcard mask when when it can advertise the right mask, even though I don't mention? See, for example, I'm not going to mention here network 333. Instead, I'll simply say network 3000. What I'm telling is, even though you said 3000 while advertising, because it's a classless routing protocol and because it is disabled, what is disabled? Auto summarization is disabled. It is going to advertise 3.3.3.3/32 only. Then you may ask a question, why do we then need to write a wildcard mask when it can? Why do I need to write a wildcard mask instead of writing like this when it can? Without doing this also, it can advertise this 32-bit prefix length. Why do I need this? If that is your question, the answer is, in case if you will have many IPs of the same subnet, like 3.3.3.1/32, 3.3.3.2/32. See, all these are starting with 3.3.3, but the end is not the same. This may be loopback 0, this is loopback 1, this is loopback 2. Now, if I do not want EIGRP to advertise this and this, and I must use the wildcard mask to advertise, I need to say only if all these 4 matches, which means here only EIGRP will run. But if I don't mention this wildcard mask, EIGRP will run on all these 3, because when you don't mention the wildcard mask, it will match only the first octet because it is class A. EIGRP will be running on all these 3 interface if you don't mention wildcard mask. See, this is one story. Auto summarization is another story. Even though EIGRP is running on all this, if auto summarization is enabled, it is simply going to advertise 3000/8 because auto summarization is enabled. Even though you mentioned the wildcard mask very clearly, this only means what? On what all interface I should run EIGRP? These 3 interface. No. Only these interface. If you don't mention this 000, when you typed without wildcard mask, it means you need to run EIGRP on all these 3. It runs on all these 3. But if summarization is enabled, this is what going to be the advertisement. No, but the newer version, I tell you, the summarization is disabled. It's going to advertise. You see, if you simply put this, it's going to advertise all these 3. because the summarization is off. I showed you. Did I answer your question, Mahesh?
Yes, sir.
Wonderful. Let us now go to stub. Okay. I'm going to configure EIGRP on the rest of the routers, and then we'll get into stub. Router 1. Where are you? Router EIGRP 100. Network is 13. Sorry. What is that? Oh, I forgot to type this command, IP routing. You see, after cancelling all the protocol by typing no IP routing, if I forget to put this command, this is what I'll get. It says, hey, this is not even a router. First enable routing feature. I enabled it now. Now I put the command, it accepts. Now networks are 12, 13. Let me check whether I have any loopback interface to show IP interface brief. Yeah, I do have loopback interface, so interface, sorry, then network. What is next? I'm expecting neighbor between R1 and R3. By this time, neighbor should have come. Show IP protocol. 12, 13 is there. No? Show IP EIGRP neighbor. It shows that it has already got a neighbor. This is what 13003 router 3. I'm right now in router 1. And here also I see. This is the 0th neighbor. Which host? This is the 0th host. 0th neighbor. VIG 4/0. Now let's go to router 2, configure EIGRP. Okay. Now router 2 also got another neighbor. Let's go back to R1 and check the neighbor statement again. Earlier when we saw, it was only 0 and 0th host and 13. Still the same, but the new host has come, the new neighbor has come, which is 12002. This is router 2. Yeah. Now next is what? Router 4. Router EIGRP 100. Networks are 4. Network or 10. Beginning with 10, we have 3 subnets. Network 24. You will see a neighbor coming up now. Yes, neighbors come. Now you got routes to reach. From router 3, I can ping router 4 and router 4 can respond to 3 back. Router 4 has got a route to reach 3333. So when I go to router 3 and ping, I should have reachability because here this also has got a show IP route 4444. See this 4444, this 10.1, 10.2, 10.3, they all come from same place. That's why they got same metric. They all come from router 4. They got same metric. 4444, this 3, they all come from same host. What is this 90? It's an administrative distance of EIGRP. Now let us ping and verify. If you simply ping, the source address of this packet will be the exit interface address 13003. When you ping it with loopback, then the source address will be 333. So when I'm pinging from 333, when you see the response, it means R4 also knows the reverse path. R4 also knows the path to reach 333. All right. Now our focus is on router 1, 2, and 3. Okay. Go to router 1 and check the routing table. Show IP route. Okay, our focus is, okay, let me just only show you EIGRP routes. EIGRP. And these are the routes. See, it's a nice small table which we can easily see what is missing or what is available. Right now, everything is available. R1 is learning these three, okay, these four from router 4. Is this summarized? No. Why? Because summarization is off in the newer version. In the older version, it was on. And in the older version, you would have seen only one line instead of this 3 line. Okay, so we are learning these from router 4 and we are learning this one from router 3 and 2222 from router 2. And please note, 24 is also from router 2 only. Router 1 learns 24 network, which is running between router 2 and 3, sorry, 2 and 4. Between 2 and 4, you got 24000. All right, we got these routes fully distributed routes. What am I going to do next? We are going to configure stub, but for that, I also want to do summarization on router 2. Why, when you simply configure stub, both connected and summary will be advertised. Other things will not be. Okay, let us do one thing. Let us start from summary. Okay, I'm going to start from stub summary. Stub summary. See what happens. First of all, I'll go to router 2 and do summarization for this 10 network. I'm going to this interface G3/0 and I'm saying IP summary address EIGRP 100. Whenever you see any network starting with 10, you just round it to this. This is the meaning of this. You may have 10.1, 10.2, 10.3, 10.4, 10.100, whatever. You are not going to advertise those detailed routes. You're going to only advertise summary route in this direction. Now you see, on router 2 itself, it will impact in the routing table. You will see a summary route pointing towards null interface. Look at this. This has come because I did this configuration on G3/0. Listen. G3/0, I configured this. But it will not point towards any interface. The meaning of that is, I'm saying whenever you advertise on this interface G3/0, you need to summarize like this. So it will not point towards any interface like G4/0 or G3/0, none of the interface. It will point towards null. We have learned this in the early class. If you go and see, we said that in order to prevent loop, it will point towards a dummy interface, a null interface. Dummy, null interface. It's not real. Fine. I want to now go and check on R1 whether I am getting a summary route. Earlier we were having detailed route with 32. There was a resync happened when I did the change there on router 2. There was a change in router 1 and now I see it is summarized. The routing table is shrinked, made small. Okay, so we got a summary route. And what about this 24? Is it summary coming from router 2? No, it's the connected network coming from router 2. Do you agree?
Yes, sir.
Thank you. So 24 is the connected network given by router 2. Router 2 will not advertise 12. Why? Split horizon. Router 2 and router 1 is having common network called 12. So that need not be advertised. Router 1 need not to learn it through advertisement. Not necessary. Okay. Now what is next? R1 is learning only the summary route and the connected network. If I'll go to router 2 now, router EIGRP 100, EIGRP Stub summary. Okay. As soon as I hit enter, a resync will happen again. Resynchronization will happen again because router 2 is going to say, I am a stub router. I would like to capture the packet and show you. I'm not sure whether it can be captured by Wireshark because EIGRP is a proprietary one. Wireshark may not have these things to capture because it's not a standard one. Wireshark is not from Cisco, no? Let's say you see all EIGRP packets are shown in red. According to Wireshark, this is something from alien world. It's not as per the standard. Anyway, I just want to see if I'll find some update. Right now I'm seeing hello packets and some layer 2 CDP packets. Let us hit enter and see. Boom. Wonderful. We got update packet. This is what I want to see. I'll stop the capture and now I'll take you up. So for a long time we saw only hello and then we started seeing some update. The update was going from router 2 to router 1. That is right. That is what configured as a stub router. Router 2 is what configured. 12002 is who? 12002 is this one, router 2. Router 2 has sent an update packet. How do I know update? Here it says update. Wait a minute, I just want to create a filter. So the next class, I no need to do a lot of work. Oh. Wonderful. See, next time, see, there are too many packets, right? Too many. I'll simply go to EIGRP tab and click update. Boom. It shows only the update packet. This is the magic of logic of magic or logic, whatever, of Wireshark. I love this Wireshark because of all these features. Now I'm going to also add another filter for our, so that in future batch I no need to search for acknowledgement packet. Acknowledgement. This is an acknowledgement packet, right? This is a problem. Acknowledgement flag. This is okay. 22, 21. It's okay. It's type 5. All right. Hopefully, this is going to show only acknowledge. No, it even shows hello packet. This is not a standard protocol, so anyway, I don't want to spend much time. Otherwise, I would have done something else. Now, update packet. This is what I want to show. Now, what we are expecting is the special message, the stub message saying, "I'm a stub flag init set," and then what? No other. Okay, I see another update packet going from router 2 here. Flag init is not set. Look at this. Here it says very clearly down here, internal route 10008. Because I said summary, no? It is not advertising 24 network. 24 is also an internal network. But the connected, it's not advertising its own connected. I would like to show you in the routing table now. Earlier in the routing table, we had this 24 network, but now you don't have it. 24 is gone, 10 is gone, 4.4.4 is gone. Only the summary route, if any, router 2 is ready to advertise. So router 2 has got summary only for this network. So router 2 has advertised only that line. And who advertised this line? Router 3 advertised this line. Router 3 will not advertise 13 network to router 1 because it's not necessary for router 1 to learn from router 3. Why? Because it is directly connected. 13 is directly connected. So, you see, earlier the routing table was having too many routes and then most of them, like, look at this. 333, except 333, all the rest are from where? Router 2. All were from router 2. But now all of them stopped coming except this summary because we said if we said in router 2, if you will find a summary route, advertise that. So EIGRP very clearly says that only this is the only thing I'm responsible. You should not ask me anything else. So you may have a question in your mind like, then how will I ping 4444? One option is, see, first of all, if you're configuring stub on router 2, either you should have a default route to reach all those networks behind router 2. And the default network needs to be either redistributed into EIGRP, or you remember earlier we did default network command in EIGRP. That should have been done, using which router 2 can reach the networks which are behind R2. Okay, now do you understand the stub summary only? The first stub I have taught you here is stub summary. Do you understand that?
Yes, sir.
All right, let's move on to the second one, connected. I'm going to go to router 2 and remove the stub summary and say EIGRP stub connected. Now what you should expect is, you should expect only 24 network advertised Only 24 network will be advertised, nothing else will be advertised by router 2. You see, only 24 is advertised and 2222 is advertised. This is also connected on router 2, loopback. Only the connected networks are given. The routes that are learned from R4, you see, if you go to router 2, you will see a lot of routes coming from R4 also. Show IP route EIGRP. You do have these things coming from router 4, but router 2 is not ready to give it. Why it's not giving? Because we have configured it as stub connected. Even though we are having a neighborship with router 4, because we have configured stub connected, it is not ready to accept. Sorry, send. Router 1, show IP EIGRP packets. Summary. Traffic. Okay, this is what SIA means, stuck inactive. I was telling you, when query is sent, the stuck inactive will be incremented to boom 1, and if response comes, then /1. If someone queries, that will become reply. Reply sent and reply received. Okay, so the stuck inactive is what we are trying to avoid. Show IP EIGRP topology. This P will become T if it goes stuck inactive. And if it is searching for this destination path, if a primary route goes down, there's only one successor. If there is no feasible successor, when the successor goes down, it will look for feasible successor by putting P into A. All right, that's why we call it stuck inactive. Now we have learned only two stub connected and stub summary. After we configure stub connected, you see only the connected networks coming from router 2. The summary is not coming. If I want to have both connected and summary, you know what to do, right? You know it. You'll go here and say router EIGRP 100, not just connected. I want EIGRP stub. Boof, only that much. I remove connected. When I say EIGRP stub, enter, I enable both connected and summary. Go to R1. Now I should be seeing the summary and the connected. So connected and summary. If I have few other networks for which I have not summarized, for example 44444, is it summarized? That is why it is missing. 44444 is not summarized. That's why it is missing. So we have learned 3 stuff. Now the fourth one. Let's say I have a static route to reach 44444 on R4. Wait, I'm going to remove the EIGRP from loopback here. Show IP interface brief. Please pay attention. This 44444 interface, I'm going to remove EIGRP. Right now, show IP EIGRP interface, it also runs on loopback 0. It is because show run section router EIGRP. It is because I put this command. I'm going to remove this. Router EIGRP 100. No. Remote. Now let us go and remove the stub that we configured on R4. And we'll go to router 1 and check. We do have 24. We do have the summary 10, but we don't have 444 because we removed EIGRP under that loopback R4 loopback 0. So what I'm going to do is I'm going to go to router 2 and write a static route. I'm saying send it to 24004. This is a static route. To make this static route available for R1 and R3, instead of going to R1 and R3 and writing another static routes, I'll simply say router EIGRP 100 redistribute static. But EIGRP needs a metric, no? So I'm giving 5 metric. These are the 5 metrics. Metric keyword I need to type. We have redistributed. All right, now in R2 we have done this. I'm expecting now 4 network in my routing table on R1 as an external. Why it is external, you know? Because we redistributed. 170 is the administrative distance for external, for redistributed. What is external? It is not from EIGRP. It is from some other source and it is redistributed into EIGRP. It is like a borrowed information. Which one you will trust? The borrowed wealth or your own wealth? Of course, your own wealth is yours. Borrowed wealth, you have to return it back. That is why the administrative distance is 170. Everything on this earth is borrowed one, God given. You have to return it. You cannot take anything except the good deeds that we do. That is our own 90. You can trust that. When I go heaven, I'll have a wonderful place, a wonderful time. That's my own. But all other things, that bungalow, the luxury, everything is God given. As long as we are here, we enjoy this in a proper way and give it to the right hand and we go. If we give it to wrong hand, then when we go there, the consequence will be different. So that is also handover also very important. Anyway, that is why the distance is